us Dr. Ajay Kumar Chauhan, sir. Sir, Ravinder, you can start the recording. It's okay. So for the session, we have with us Dr. Ajay Kumar Chauhan. Sir is working as the director, FPM at UBS Mumbai. Sir is the international consultant of quantitative methods. He is a visiting faculty with MDI, IMT, NMIMS, IFT, NIT, to name a few institutions. Earlier, Sir was associated with IMT Ghaziabad as a full-time faculty for 8 years. Sir is a MSc Mathematics, MBA Finance, UGC NAT, and has done his PhD in Finance. Sir has published, and to his credit, has more than 25 international research papers, including some in ABDC journals, A category and B category. And to his credit, Sir has 3 books as research publications. Sir is a well-known trainer of data science and analysis and has conducted more than 1,000 national and international training workshops on topics like financial econometrics, time series analysis, machine learning using R and Orange, SEM, panel data analysis, business research methods, to name a few. In different reputed institutions of India like NHPC, Coca-Cola, IMT Ghaziabad, UGC Academic Staff Colleges, IIFT Delhi University, NHPC, National Institute of Technology, that is NIT, IIT, Ministry of Communications, and many more. Sir has also taught in Bulgaria and has done an advanced course in econometrics from Switzerland. Sir specializes in research methodology, qualitative and quantitative methods, business statistics, quantitative finance, and business analytics. And to this, I would really like to add that as a person and as a teacher, we have been associated with Sir for now almost 5 years. And definitely never ever Sir has ever denied our request to be a part of the refresher course, whether we are requesting it in our colleges or we are requesting it in TLC Ramanujan College. For that, Sir, I use this platform to really acknowledge my gratitude for that, for all the cooperation and the support you always provide us. Thank you so much, Sir, for agreeing to be the resource person for this session. And definitely, I just hope that the session is going to be as enjoyable as always, Sir, which was there in past also. Thank you so much again, and over to you now. Thank you, sir. Sir, for the session, we will have Dr. Rajiv Nair, who will be there, sir, to help you coordinate through the session. Thank you, sir.
Okay. Okay. Good evening to all of you. So today I will speak on 2 topics. The first one is the neural network, how we can use neural network. And the second topic is discriminant analysis. So these are the 2 topics which we are going to discuss today. So I'm going to start the topic number 1. So that is the ANN. Okay. And I will demonstrate the SPSS software to perform the ANN with the 2 data set. Okay, so myself, Dr. Ajay Kumar Chauhan. Let me slide share. Yeah, I hope you can see this slide. So, first of all, we have to understand the concept. Although ANN is very typical and it is like a black box. So what is going inside, we don't know. But the logic we have to understand. So artificial neural network consists of 3 words: artificial, neural, and network. So we have to understand the 3 words to understand the ANN. The first word is neural. So this neural word is coming from neurons. And so what are these neurons? The neurons are available in the brain. Here, the neurons are here. So inside the skull. And how many millions, billions of neurons? And if you understand the algorithm of the neurons, like for example, if you talk to your child in Hindi or English, he can respond very fast. But if somebody communicate in Chinese, your child may not answer. Why? Because your child learned the English and Hindi, but not Chinese. So so the neurons are continuously learning the things. So we are learning day by day. And on the basis of our learnings, we take the decision on anything. And this, the brain of the human is divided into different layers. Like conscious mind, subconscious mind, right? So the output which we are taking, like in the form of a decision, or in simple language, whatever decision we are taking is the outcome of the functions performed by many neurons located in subconscious mind, conscious mind, different layers. So
Just
please
muting
mute
it in a
somebody.
second, sir.
Yeah. Yeah.
राजीव सर, आप
Please.
सर आप कर पाएंगे सर?
Okay, ma'am. Okay, ma'am.
तुषार सर, आई एम जस्ट रिक्वेस्टिंग यू टू म्यूट योरसेल्फ. सर आप कर पाएंगे?
Yes, ma'am. मैं कर रहा हूँ, ma'am.
ओके.
Yeah. So what we are talking about, the neurons, and all the millions of neurons are connected to each other, and they are working parallelly. They are processing parallelly. So most of the neurons are working parallelly. So this is one of the property of neurons. And the best computer in this world is the human mind. So human mind is a supercomputer capable of performing millions of activities within a minute. So from this concept, the ANN technique emerges. Okay. So the ANN, artificial neural network, resemble brain in two aspects. So these two aspects are number one, every output is a process, is an outcome of the learning process. So knowledge is acquired through our learning process, right? So brain actually learns. If you see the learning process of a small child, how he learns, you can understand the algorithm of the learning through your neurons. So all the neurons are connected to each other. And the another thing which is important here, that we are assigning the weight to the different inputs. Like in regression model, you are having beta 1, beta 2, beta 3, beta 4. So in simple term, they are the weights. Some variable is more important, some variable is less important. Some variable is not at all important at all. So by learning, we are assigning some of the weights to the different inputs. And on the basis of these inputs, we decide about the output. So you can see that it is a brain. All the neurons are connected to each other. Some circles are big, some circles are small. So we are assigning different weights to the different inputs. Now the another concept is artificial, because the definition of full form of ANN is artificial neural network. So neurons we understand. The same way brain works, the same way we want to machine to work. So that is called artificial. So artificial means whatever algorithm we are using in our mind, our brain, the same algorithm we are trying to replicate it by the machine. So trying to replicate the same process with the help of an artificial machine, that is a computer, and is a popular tool of the prediction. So we are applying the algorithm of the neurons in a machine. So that is called artificial. And because we are combining different neurons to each other, so it is nothing, it is a network of the neurons. It is a network of the neurons. So in total, we call it the artificial neural network. So neural network is looking like this. So what is a neural network? A neural network is the combination of three things. There are three things. Like for example, whatever decision we are taking is the output. If I show you picture of Amitabh Bachchan, and you are telling me that he is Amitabh Bachchan, so you are taking a decision, and this decision is based on many information which is lying at different layers, right? Your subconscious mind, your conscious mind. You may watch many movies of Amitabh Bachchan. So all these information comes, and you will take a decision that this person is Amitabh Bachchan, right? So the neural network is actually used in different cases, even in the case of face recognition. And there are many complicated markets, like the stock market is very complicated. So with the help of this neural network, to some extent, we are also try to understand the stock market, behavior of the stock market. And I don't know whether you heard about this or not. There are many people even who tried the neural network to find out the lottery, whether who will win, what is the next number, right, which is coming in the lottery. So there are many intelligent people who are using the neural network to even predicting the lottery. So neural network is that important thing. In this picture, if you see this picture is consisting of the three colors: green color, blue color, and this is red color. The green color is nothing, it is a input information. So this layer is known as input information, input layer. And the blue circles are basically the hidden layers. This is called black box. Why this is known as black box? Because it is very, very difficult to understand the algorithm in these layers. It is an iterative process. So it is very, very difficult to understand the hidden layers. So the hidden layers are known as black box. Output layer is known to us. Output layer means what decision we are going to take. So that is called output layer. So the how we define the neural network. A computational neural network is a set of non-linear data modeling tool. Now, the words are very important here. So I'm saying non-linear. Non-linear. Because complicated relationships are not linear. Complicated relationships like the stock market, commodity market, exchange rate market, interest rate market, and the marketing, they're not linear, they're non-linear. So one of the advantage of neural network is its ability to capture the non-linear relationship between the variables. So it is consisting of input and output layers. As I told you that in every neural network, so you are having the input variable, output variable, because in data set we are having the input variable and output variable. In a network we call them layer, but in data set they are the variables. And between the input variable and the output variable there are some hidden layers, and that is called black box. It is just impossible to understand these layers. Okay. The connection between neurons in each layer has associated weight, right? Like I'm giving you a very simple example. Suppose if you see a car, and if I ask you that whether it is a car or a truck, or if you see Akshay Kumar or Kareena Kaif, if I ask you that can you tell me that whether this picture is of Kareena Kaif or Katrina Kaif or Amitabh Bachchan? So here gender is one of the important variable which is having important weight. If you are differentiating the car with a truck, then size is having the important weight, because both are having four tire, everything is same. Only thing is that size is different. So you are giving more weight to the size, right? Maybe you are not giving equal same weight to the tires, because tire of a truck is heavier, size is more bigger. So you are differentiating on the basis of some variable, and each variable are not equally important, they are different important. So you are giving more weight to one variable, less weight to another variable, and on the basis of these weights you decide. So the connection between the neurons in each layer has associated weights, which are iteratively adjusted by the training algorithm. Because whenever you learn something, you learn slowly and slowly, right? So there are many cases like in data science. So when you open the software, in first round, you may not understand many of the things. But when you do twice, right, your learning will be high. When you do it many times, your learning will increase. So neural network based on the iterative process. You are doing again and again, again and again, again and again. And after some time, you found that now you are comfortable with it. So same thing we will do in ANN. And the objective is simply, if whatever machine learning technique you are applying, whatever mathematical model you are applying, one of the objective is to minimize the error, prediction error, or to increase the accurate predictions. So there are only two objective of all the techniques. Similarly in ANN, we are having two purpose. One is to minimize the prediction error or to increase the predictive accuracy. There are many people who are asking me, why? क्यों use करें? Why to use this ANN? So they say that it is very, very difficult to understand the ANN. So can't we use any other technique? Okay. So there are some logic of using the ANN. Number one, if you apply a regression model, you have to check whether the data is normally distributed or not. Sample size is 10 times than the variables or not. Then the linear relationship is there or not. Do you have multicollinearity, autocorrelation, heteroscedasticity? So there are so many assumptions. This is one of the best reason of using ANN, that here we don't have any assumption. So we don't have any assumption in ANN. No problem of the model assumptions such as normality, linearity, etc. Because whenever you are going to apply SAM regression. So first of all, you have to fulfill the assumption, then only you can apply the technique. Here, no assumption. Enjoy. Second, in normal data set, you need to remove the outliers. If your sample size is less, you have a problem. So there are many many type of outliers or noise in the data set. So there is a problem in the data always, sometimes, like outliers, sample size. Here, no problem. If you have sample size less, no problem. If you have outliers, no problem. If you have noise, no problem. So this is one of the another reason to use ANN. And through several rounds of learning process, the errors can be minimized and the accuracy of the prediction can be further improved. This is also one of the important reason of using the ANN, because in this case, learning will improve with the iterative processes. It is more robust and can provide higher prediction accuracy as compared to the linear models. And if you ask me, there are very few predictive models in statistics, hardly 15 or 20, like discriminant, logistic, regression, then descent tree, then random forest, right? Support vector machine. So ANN is also taking its place slowly and slowly. So whenever you are applying logistic or discriminant, you have to compare the result with ANN to show that why my technique is better than ANN. If your technique gives better result than ANN, then apply, otherwise not. Okay, so these are the areas where neural network is very, very popular. Image compression, stock exchange prediction, handwriting recognition, salesman problem. So these are just few, and I take this picture from the internet. Otherwise, nowadays you can apply neural network everywhere. Okay. So I am giving you some of the technical definitions first before going to the practice. So I will take hardly 10 minutes more, and then we will go to the practice case study. So number one, algorithm. So what is the algorithm available in the neural network? There are two famous algorithms available in the neural network. This is known as multi-layer perceptron, MLP. And second is the radial bias function, RBF. And if you see the research papers on neural network, 90% of the people uses multi-layer perception, multi-layer perceptron. More popular, more accurate. Only problem is that it is taking more time as compared to radial bias function. Why? Because a multi-layer perception is based on hidden layers. If you have more number of hidden layers, it will take more calculations. So speed is slightly slow, but accuracy is very high. If you decrease the number of layers, speed will increase, but the time speed will increase, but the accuracy will come down. So we are having two algorithm in ANN. Number one is multi-layer perception, which is based on hidden layers, and radial basis function is another algorithm which we don't never used. So multi-layer perceptron work with many hidden layers and takes more time. Both of these algorithms are, you know that in machine learning there are two types of techniques, supervised and unsupervised. So neural network is a part of supervised model. It is not a data mining technique. It is a supervised technique. So in supervised technique, we provide the input data, output data, and let the machine decide the relationship between the variables. The second property of ANN is they are using feed forward architecture. Now, what is feed forward architecture? Feed forward architecture means there are two types of movements in the data. Like, for example, if I ask you some answer, some question, like, for example, recently, which is the best movie you have seen? Like, I'm simply asking your query. And you will give me the answer within 1 minute, I know that. But the question is that what is the flow of the information in your mind? So there are two types of flow of information. Number one, from the input to the hidden layer to the output. And in second case, input to the hidden layer to the output, then back to the input, hidden layer output, back to the input, hidden layer output. So both ways it works. So the information is moving from the input, some processes in hidden layers, and then you will tell me the output. In this way, the human mind works. The only problem in neural network is that there is no mathematics which can be explained in neural network because it is a iterative process. Now, what is the iterative process I am telling you? If you try to understand, let me explain. Suppose the software assigns some random input to the different independent variables, and with the help of these weights, the software try to predict the output and compare with the actual. Then software will change the weight and predict the output and compare where the error is less. If error is less in the first case, then the software remove the second case. If error is less in second case, the software remove the previous case. And this process is going on. This process is going on. So basically all the algorithm, those who are doing the programming, so they do the programming in such a way that the weights of these independent variable are changing very fast, and software calculated the error terms, and software within few minutes will tell you that this is the best model that which gives me the best of the accurate predictions. So that is the model. So this feature is known as feed forward architecture. Now the next concept is, this is a technical concept. How many input layers should be there? how many output layers should be there, and how many in middle layer, hidden layer we should have. Now, there are simple rules for that. Number of neurons in the input layer is equal to the number of independent variables. Suppose if you have 5 independent variables, it means in your input layer there are 5 neurons. If you have 3 independent variables, it means you are having 3 neurons. And if you are having 10 independent variables, you are having how much neurons? 10. And it is not very easy like this. Now, output layer. Okay, one thing I'm telling you that there are 2 types of independent variables: nominal and scale. There are 2 types of independent variables: nominal and scale. Like gender is a nominal, and advertisement is a scale variable. So whether the nominal variables are known as factors, the nominal variables are known as factor, and the continuous scale variables are known as covariate. So in this terminology, we are going to use this terminology. So if you have any independent variable categorical, define as a factor. And if you are having a scale variable as an independent variable, defined as a covariate. Now the next is output variable, dependent variable. In dependent variable, we are having different cases, like you can have single independent variable or multiple dependent variable. In some cases, we are having the single dependent variable. In other cases, we are having many independent variables, so both possibilities are there. If you have single variable, 1 neuron. If you have multiple variable, many neurons. So number of dependent variables is the number of neurons. Now another case, when you are having continuous variables, then number of neurons are equal to number of continuous variables. If you have only one continuous variable, only 1 neuron in output layer. If you have categorical variables, suppose you are going to predict that this person will die or not. So there are 2 categories: whether die, whether not die. So in this case, there are 2 neurons in the dependent variable. So in case of dependent variable, number of neurons is equal to number of categories. Number of neurons is equal to number of categories. So, and now the layer which is left is hidden layer. So hidden layer means any number between number of dependent variable and number of independent variable, you can decide any number of hidden layer. Suppose you are having 2 dependent variable, 10 independent variables, so hidden layer may be any number which is between 2 and 10. Okay, I hope you are understanding. So dependent variable. There are 2 types of dependent variable: scale dependent variable or categorical dependent variable, or both. Now, when you are having continuous dependent variable, like for example, stock market, exchange rate, interest rate, these are all continuous dependent variable. So if you are having continuous dependent variable, then software will calculate the root mean square error to check the predictive accuracy. So this point is very, very important. If you are using continuous dependent variable, then software ANN technique will give you what? The accuracy of the result by measuring RMSE, root mean square of error. Now, if you are having the categorical dependent variable, so in this case, the software has to predict the dependent variable whether it belongs to category 1 or category 2. So then the software will gives you the confusion matrix. And on the basis of the confusion matrix, you will decide that what is the predictive accuracy. So these two are the type of dependent variables. So on this example, on this basis, I am taking the two data set. In first of the data set, I will take the continuous dependent variable. And in second data set, I will take the categorical dependent variable. Okay. Now then we are coming to the hidden layers. And because hidden layer is a black box, so it is very, very difficult to decide the number of hidden layers. So hidden layers contain unobserved network codes units. It is an unobserved network. Each hidden layer is a weight or is a function of the weighted sum of the inputs. So actually we are providing the different weights to the inputs. On the basis of this function, we are predicting the output. Right. Now in this hidden layers, the simple concept is that large number of hidden layers will increase the accuracy of the output. Less number of hidden layer is giving you less accurate output. However, time taken is more when you are having more layer. Okay. So one of the most widely known empirically driven rule of thumb is that optimum number of hidden layer neurons is between the number of input and number of output variables. It is a by default rule of thumb. Now, after that, there are many people who are giving their formulae. So you can see the different formulas given by the different person. Every person have given the different formulas. So somebody say that the number of hidden layers is equal to square root of n into 1, n into L. But frankly speaking, most of the softwares are giving you the options to select automatic. So we give automatic command. Better to leave this descent to the software, because why to spoil the model by fixing the layer? So better to leave to the computer. Computer will decide the number of layer automatic. Okay. Now, another important thing is that there are three types of data set. There are three types of data set: training data, testing data, and holdout data. And now, what is the difference between them? What is the difference between training data, testing data, holdout data? In machine learning, it is a usual practice to divide the data into two parts: testing data, training data. Training data is that data on which you are developing, you will develop the model. So I repeat, training data is that data where you develop the model. Testing data is the data where you test the prediction, how much the model is having predictive accuracy. And holdout data is that data which is entirely new data set, and you are testing your model on this data to check the validation, to validate the data. And it is the final validation. So basically there are three layers, three partition. 70% of the data you can keep for the training purpose, means train the model on 70% of the data. On 20% of the data, you test it, and assuming that the last 10% data is entirely independent, check the model validation on holdout data. So it's your choice to divide the data into different ratio. The most popular ratio is 90-10, 90 training, 10 testing. Normally people don't take holding data. You can take holdout data if your sample size is too large. So the ratio in that case 6:3:1 or 0.7 to 1. It's your choice. Is entirely your choice. There is no rule of thumb in this. So you can take the ratio like 6:3:1 or 7:2:1. So whatever you feel like. The ideal is 6:3:1. On 60%, train the model, test the model on 30%, and again test the model on the rest of the 10% to validate the final model. So this is the partition of the data set. And software will ask you that in which ratio you want to do that. So we will see it. So yeah. So SPSS output I have to show you. So these are some of the output which comes in the neural network, and let's do it with the help of example. So first of all, I will show you on a scale dependent variable, and then I will show you the model on the categorical independent variable. One thing which I cannot do now, I cannot check the result of the model with the reference model. Okay, I will explain what it is. So I'm going to open the SPSS, simplest software. We can also do in R, Python, Orange, many other softwares, but due to shortage of the time, I'm showing it on SPSS, the basic software. So I'm opening a new dataset. So I'm importing the file. So I have the dataset with me in a desktop.
The SPSS screen is not visible.
Let me check. Yeah, you are right. So I change my screen again.
Now it's visible, sir.
Yeah. So this is the indication that you are listening to me. Thank you. Okay, so I think I have data in Excel format. This is the first data set. So software is going to open this data set for me. Okay, in this data set, so I have these number of variables. Purchase is my dependent variable. This is the target variable. Target variable means output variable. So here we can also define as a target variable. Purchase intention. So my target variable is the purchase intention. All other variables are my independent variables, so I'm not naming them. Okay. So normally we apply the regression model to find out that which of the variable is more important. Okay, let me take these variables. So by looking at the regression model, I'm not here to explain you regression model, but only one thing I want to see, that which is the two top two variables. So my top two variables are this 10 and 7, age and explorer. So this I have in my mind. Now I am going to the neural network and I'm going to multi-layer perception. Okay, now you have to tell me most of the things. Which is my target variable? This. Factor means software is asking you, do you have any categorical variable? So this I have categorical variable, but let me check whether software will take it or not. And how many variables are covariate? Covariate means scale variables. So I define them as a scale variable. Before doing it, I have to check one thing. So why it is a string and why it is string? Okay, actually I defined as a string. So that is a problem. I cannot take these two variables because software will work only on number. So I have to convert them into a number. Otherwise they will not be acceptable. So software will not allow these string variables because I have to code them, frankly speaking. So I'm not taking them. So these are the variables which are there in the file. Then software will ask you, do you want to rescale the variables? I said yes, no problem. The software will make the standardized rescaling, means converting into Z-score. So there are different type of rescaling. So I'm going to standardized. Partition. Now software will tell me that how many partition, how you do the partition of the data. So by default is 7:3. 7 is training program, training data. 3% is test data. So when you repeat the exercise, you have to do it many ratios. But I'm going with it. No, not a problem. If you have any random variable, you can assign the random variable here. Architecture. So I click on, so I continue with this, not a problem. Now the software is asking you the architecture. So you have two options. Either you make your customized architecture. In customized architecture, you have to apply the function, activation function for input for hidden layer, function for the output layer. So if you have the mathematical knowledge of all these things, then you can customize. Otherwise, as a layman, do the automatic architecture selections. The software will select its best. Training. So we have to do the batch training, gradient. So we have to click on this option, gradient descendant. And in my PPT, I also put this command so to tell you that what to select and what not to select. So we are going to the batch training, gradient descendant. Then go to the output. In output, if your dependent variable is a continuous, so you can click on these output. If you need these charts, you can click on these charts. Okay, so the output independent variable importance analysis is one of the important output. And these three things we don't require. We don't want to save anything. We don't want to export anything, nothing else. So save, export, and options are not important. You can leave it. and OK. So after that, the software is giving me the result, though the result is coming. Okay. Now the question is how to report the results. So that is the most important thing. So you have to report this table. If you see all the research papers, so research paper will report only two tables. Table number 1 and table number 2. Table number 1 and table number 2. So if you see any paper of artificial ANN, so the table number 1 is reported and this table and this table. So unfortunately, these two tables are not available. So we have to make this table. So this is the most important part, that how to make these tables. So for that, I'm going to open an Excel file. And so I will show you how to make the calculation part. So some calculation we have to do. Okay. So let me show the, because in this case, our dependent variable is a scale variable. So we want to find out two things. What is the root mean square of error? And second thing is which is the most important variable predicting the dependent variable. So because we have clicked now on many outputs, so there are so many output is coming. Yeah, so this is ROC curve. Now let me explain the ROC curve. Otherwise, if you want to report in the paper, you can report. Okay, Excel भी खुल गया हमारा. So let's open the new file. So what I need in Excel, SSC, sum of square of the errors. So this is SSC means sum of the square of the errors. Training. Then we are having SSC testing, because you know that there are two set of data set. Then RMSE training, RMSC testing, and this is the difference of RMSC training minus testing. So these 5 things we have to calculate. And believe me, it is very easy. Don't worry about it, because you have to take this table to the paper. If you are interested to write a paper on this, so you need to calculate this. And one thing which is very, very important, I have to run at least 10 inputs, 10 times. I run the same command 10 times. I have to run the same command 10 times. But due to the time limitation, I will repeat 3 times. Otherwise, you have to repeat 10 times. Now, this is the sample size training. This is the sample size of the testing. Yeah. So we are calculating all these things. So first calculation I am going to show you. So I was explaining ROC. Let's discuss ROC also. So you can see that there are 9 input variables in the file. Dependent variable is this. So if the model is the worst, then all the lines are near to this straight line. And the curve which is the farthest from this straight line is the best. So in this way, we understand the ROC. So let me explain one by one. The software also give you the layer. Okay. Actually, what happens in this case, the software take the dependent variable as a category. So that is the problem, because software is converted dependent variable into 9 layer. When purchase is 1, when purchase is 2, when purchase is 3, when purchase is 4. So I have to check why the software is taking this as a this variable. Oh, I defined it as a nominal variable. So this is a mistake. I defined my dependent variable as a nominal variable. So that's why the software is converted this dependent variable into category. So that is a mistake. So we have to do it again, because I want to declare this variable as a scale variable. Otherwise, the software will convert into a category variable. So now I think is fine. Okay, so let's do it again. Neural network, multi-layer perception. I think all the commands are same. And okay. Now you will get different type of results. So first of all, we have to note down something like in training, the sample size is 290, 110. So 290 and 110. So this we have to note down every time. Okay. So the percentage, the software is taking 72%, 27%. Although we decided to give 70-30, but software make changes, slight changes. That is not a problem. So one thing you have to report in the paper, that activation function is hyperbolic. In output layer, the activation function is softmax. This is for reporting the research paper, that in hidden layer, the function applied is hyperbolic tangent. In output layer, the activation function is softmax. Otherwise, we don't know what is this algorithm. Okay. Again, the software is taking 4 sets, 9 categories. Okay. So I have to take some other data set, because in software, converting the data into categorical is still categorical. Okay. So one thing which I also show you. So in this, this is one of the very important chart. The software is giving you which variable is more important, which variable is less important. So this is one of the important output. The explorer is found to be the most important variable as per the ANN method, and fashionable is found to be second most important variable, and these importance is given here. So the software is giving you the normalized importance. Normalized important means the variable which is highly important is assigned to the one weight of 100. So in comparison to this, all other are automatically converted. So the most important variable according to the model is explorer, fashionable, age, optimistic, family, finance, leadership. So this is the second output which you need to report in the paper. So this is called relative importance. Yeah. And one thing which I am going to repeat in this data set, this table is also one of the important output. So you have to take the output here. And whenever you run ANN, you have to run at least 10 times, as I told you before. I'm just here running it 5 times because I want to show you the difference in the results. So this is my first result in case of importance. Then I will run. I will delete it and run another time. Just click OK. So the problem is that every time you will get the different result. Now, this is the result. So let's copy it and let's take here. So you can see that the results are slightly different. So I cut it and paste here. So you can see that previously finance is having 31%. Now it is 27%. Still, there is no change in the Explorer. But if you see all other cases, there is a change in the weights. 74 is becoming 66, 32%, 24. So whenever you run NNN, you have to run at least 10 times and then take the average. Let's take one more time. Because this is one of the important output, whether the dependent variable is categorical or scale, that is not a problem. This you have to do always, many times. Okay. So again, I'm running one more time and taking this value. So this is one of the most important output that the software is giving me. So every time I have to take it and copy it. Okay, so we have to copy it carefully. I will not repeat much, but the thing which is I want to show you is that there is a huge variation in the results. So in ANN, this is one of the problem that whenever you run the file multiple times, every time you will get the different result. So the usual practice of running ANN is that you have to run at least 10 times. So let me run one or two more time. Every time you have to remove the previous result, otherwise there are so many results. Okay, so this is the fourth result I'm getting. Okay. So now when you do it 10 times, you will take the average of that. You have to take the average of all the 10. So here I am taking the average of 4. And after taking the average, you take all the independent variables, paste here, and plot a graph like this. So this graph is telling you that which variable is the most important variable is predicting my dependent variable, which is Explorer. So you can make so many changes into it. So I think this is looking better. Let's remove the grid lines. Okay. Now you are getting this table, which is you have to paste in the research paper. So in research paper, you have to see this also, that the most important variable predicting the dependent variable is Explorer, followed by age, then fashionable, then age, then optimistic. So 1, 2, 3, 4. 4 variables are the most important variables predicting the dependent variable. So this is one of the important output you have to take to the paper. So you can see this output. So we run it 10 times and take the average and report in the paper. Now I have to show you this table. This table. This table only we will get when the dependent variable is my scale variable, not category, because even in this case, the software is taking its category. So let me take any skill ratio skill variable, continuous variable rather. Okay, so I hope it is clear from this part. Yeah. So this is also one of the important table which is to be reported in the research paper. This table is known as the confusion matrix. This table is known as confusion matrix. The software will tell you that how many percentage correct values are there. Like for example, in predicting the category 1, the accuracy is 9.7% in training data. But actually, we never apply when there are 9 categories, so it is not a right table to show. But if you have 3 categories, 4 categories, 5 categories, maximum 3 categories we will work. So you can identify that which category is predicted how accurately. So unfortunately, I took the wrong data set for my result. Right. So overall percentage is only 31%, and it is because there are too many categories. So let me finish this because this is a confusing data. So let me take any other data set, which is a finance data set. So I'm opening another data set, which is a pure continuous data set. So give me a minute to open the data. So meanwhile, if you have any query, please ask. It is taking time to open the data set. So let me try to find out the data. If you have any query, please ask. Okay, great. So now I'm opening a pure continuous data. So in this data set, I have the gold price, crude oil, USD, Nifty, bond, and event we are not taking. It is a, I think, yeah, categorical data, dummy data. So let's apply in this case. So the question is that can we predict the Nifty on the basis of all other values? So neural network, multi-layer, Nifty is my dependent variable. So we can convert into a stationary variable also. That is not a problem, but just I'm telling you the method. And these are the variables are covariates. Event is a factor variable. So if you want, you can take it. Otherwise, leave it. And partition is same 7:3. Architecture automatic. Training, batch training, gradient output. So now you can see that the software is not able to, you are not able to click on these. Why? Because here the dependent variable is continuous. So you are not able to click on this. So only thing is that you can click on these. And important analysis, which is one of the important variable, not anything. So now we just click on OK and got the output. So here the training data set is 2829121917. So let me take this value. So now I'm going to tell you how to make the table number 1. So I paste here. The sample size of training is 2829 and this testing is 1217. Okay, so all these values I'm deleting. I will show again. So let me delete the previous data set. So this is the first run. We have to run at least 3 times. Another output which I want is the this is a neural network diagram, not very important, but you can show in the paper. It is just showing the dependent variable, independent variable, and the hidden layers. Okay. Now this table is very, very important here. Let's copy it. Model summary. And some values we are taking. Oh, so let me note it down. Let's take directly. So this is training data set. You can see it is 57.701. So you have to take sum of square errors. 57.7 training. So it is 57.7. And the testing is 24.395. 24.395. So 2 inputs are required. Number 1, what is the sum of square error and sum of the error of training and testing. These are the sample size. On the basis of these 4 values, you have to calculate RMSE training and RMSE testing. How? By applying this formula, square root SSC upon N. So because this RMSE is the only important thing which you have to report in the paper. So it is SQRT divided by this value upon sample size. Okay. Similarly, we can calculate for this also. SQRT, this value upon this value. So decrease the decimal numbers. And this is the difference. The training value minus testing value, like this. So it is almost 0. and you can increase the sample decimal point. So we have to do it 10 times, and then you have to plot of this graph. You have to make the plot of these two or these two or these three. So this plot is showing you the difference of the prediction error between the testing data and the training data. So let me do one more time. The same thing we can do on the importance variable. Okay. So again, one more time I'm doing it. Neural network, multi-layer perception. And okay. So it is 2807. This is 2807. Every time the sample size will change. And in testing, it is 1239. 1239. These two values we have to take. Similarly, we have to take the square of the error terms. 47 4748 2182 4748 2182 47.48 to 1.82, and you just copy it, drag it, and this. So if you, whenever you see any paper written on ANN, so you have to show this table along with the sample size also. So what is the purpose of it? You have to show that the difference in the root mean square error is very less. And even this is RMSE is very, very less in case of ANN. Sometimes we are comparing the result with the logistic regression and other methods. So we have to compare RMSE of the different models. So if RMSE of the model with the lowest value of RMSE is considered to be the best. So in this way, we want to prove that neural network is one of the best robust method for predicting the dependent variable. But because it is a learning process, so you have to run the command 10 times and take the average of that. Similarly, you have to take the average of the importance. Like for example, if we go below, so here the software is telling me the most important variable is gold, followed by exchange rate, followed by bonds, I think. Crude is, so the software is telling me that which variable is the most important variable. But this is just only one output. So you have to take the 10 outputs and take the average of the importance and take the average of the normalized importance. So after taking the 10 outputs, taking the average of the 10 outputs, then only you can shift. You can say that after the 10 run, the average highest importance is found to be this variable, and so many, and whatever, you can arrange all the important variables in descending order. So I have seen some papers where they are comparing the SAM model, neural network model, ARIMA model, neural network model, logistic model, neural network model. So this is one of the way of writing the paper. And if you are comparing the ANN with the SAM model, so it is one of the scope of writing the paper. So in short period of time, I tried my best to explain the concept of ANN. So I hope you are having idea about what is ANN, how to run ANN in the SPSS software. So that's it from my side. And if you have any query, Please ask. The After some time, I will start a new topic on discriminant analysis. So I'm waiting for the query. Otherwise, we are going for a break, short break, 10 minutes break. After 10 minutes, I will start the discriminant analysis.
Okay, sir. Just for the break of the 10 minutes, sir.
Yeah.
Okay, sir. I request to all the participants not to exit
Okay, so now I am going to start the
Yes, sir.
second topic,
Okay, sir.
that is discriminant analysis. Okay, so discriminant analysis, discriminant means discriminating. Basically, we are having the natural habit of classifying. Okay. So why this technique is known as discriminant analysis? The one of the reason is that we are dividing our dependent variable into category. So normally we are having the dependent variable like this. So we have a dependent variable y in a regression equation. Y is equal to alpha plus beta 1 variable 1 plus beta 2 variable 2 and so on. It is a normal regression model. In a normal regression model, this y variable is a scale variable. Is a scale variable. And the independent variables are the combination of scale variables plus category variables. Okay, it is a normal regression model. So, but we are having a special case when we convert this y into category. So now our y is a category. So this is the special case about the discriminant model. And if I ask you that what we are going to predict, so we are predicting the category. Here we are predicting the category. In a normal regression model, we are predicting the value of the dependent variable, but here we are predicting the category. Like for example, whenever you are hiring a employee, you can put the employee on two categories, like high performing employee or less performing employee. So similarly, bank divide the customers into two categories, subprime customers and prime customers. So we have a habit of making the categories. Similarly, in academics, we divide the teachers into two categories, the teachers and the researchers. So those who are doing the good research, we call them researchers, and those who are good teachers in the class but don't do the researcher, they are the teachers. So categories. Now the question is that can we predict the categories? Can we predict the categories? Answer is yes. We can predict the categories. So when you invest in a share, your investment will be converted into two categories, loss and profit, right? And you are always interested to know how can I predict the category. Suppose I'm going to invest in a new share, how can I predict that this may belong to my profit stock or loss stock? So that is the natural question which comes in the mind. And so when we decide the category first, so in this case, we are deciding the category first. Then we try to find out the reasons. On what basis we can classify them, right? Suppose you are having two categories. One is dog and second is cat. Now the question is that how can we categorize that this is a cat and this is a dog? So you have to start finding out the variables. Like for example, you can take the variables like number of legs, barking, then size. So you identify so many variables, and some variables are significant variables which can classify between dog and cats. But there may be some variables which you are not able to classify. Like for example, all the dog are having 4 legs, cat are having 4 legs. So on the basis of the legs, we can't classify. But on the basis of the barking, we can classify that if somebody bark, we can say it is the dog, and cat don't bark. Size, big size dog, very small size cats. So we have to identify the independent variables on the basis of which we can classify the categories. So this is where we make the model. But the problem with discriminant validity is that discriminant analysis is having only one problem, that is called linearity. We assume that the relationship is linear. In practical world, the relationship is not linear. So if you are having two categories, discriminant analysis can be replaced by logistic regression model. The analysts prefer logistic regression over the discriminant analysis if you are having only two categories. And more than two categories, you can go to the neural network. Okay. Now, so one thing which is, I think it's clear in your mind, that discriminant analysis is for classification. How to predict the classification. Banks normally, if you approach for a bank for a loan, the bank want to analyze that whether you will be a default or you will be not a default. You will be regular customer. They want to know that whether you will be a default customer or you will be a normal customer. This is the same way when you do the investment in the stocks. You want to know that whether I will make profit out of it or I will make a loss in this investment. Similarly, they want to know. So almost every bank nowadays, they are using the predictive models. Although there is one problem with the predictive models, because I was talking with one of the person. So she said that we provided loan to many companies, and in one morning we came to know that the 3 companies are going to be bankrupt. Like these 3 companies were the India Bulls Housing, Diwan Housing, and ILFS. And one day before, nobody can imagine that these companies are facing a problem. So even these kind of models are also cheated the people. Means you are not able to predict well. So you have to add some qualitative variables also. Like now she say that if there is a high turnover in the company, it is one of the indication that something is going to be wrong in the company. So they are using some more indicators also. So the question is that how we can develop a model like this. So today I will tell you that how to make a model on discriminant analysis. So the application areas of discriminant analysis is when you want to divide the people into different categories, like potential buyers, non-buyers, used by credit rating agency to rate individually to classify them good lending risk or bad lending risk. So linear development analysis can be used to classify object into two or more groups based on the knowledge of some variable related to them, like unsuccessful salesman, successful salesman, high risk, low risk, okay? Like this. Okay. Now my discriminant model looks like this, where y is my dependent variable, and dependent variable is a categorical variable which I write here. In the discriminant analysis, the dependent variable is always a category variable. And independent variable may be the combination of the continuous and categorical. Okay, so I think this is clear to you. Okay. Now, with the help of the data, we try to develop a model, and that model will predict the new candidate whether he will fall in category 1 and fall in category 2. So rest of the things I will show with the help of the data and SPSS output, so that will give you more clarity. Okay, so I'm using a data set that is a credit card data. Actually, what happens in bank? So most of you are using credit cards. In credit card, we are having a facility that if you pay the bill amount in 50 days, they will not put any charge on you. So you can put the amount in 50 days normally. But after 50 days, you have two choices. Either to pay the minimum amount or to pay the full amount. Suppose you are not having the full amount, you are having a small amount and you pay the minimum amount. In that case, paying the minimum amount is an indication that you are having some financial problem in this month. Next month, you can pay the complete amount. But from bank point of view, now bank becomes alert. This person can do the fraud, not fraud, the default. So they will reduce your limit and be cautious that you are not spending too much. So they keep an eye on your spending. Next month, if you are again continue to pay minimum amount, then they will take some corrective action. It may be possible that they will put you in the category of high default category, high default risk. So now the customer, the bank is having existing customers. So they are dividing the customers into two categories, 1 and 2. So 1 means where the probability of risk is high, and 2 where the probability of risk is low. So if I show you that, so 1 means where the probability of default is high, and 2 means where the probability of default is low. Okay. Now I have these independent variables to use: the age of a person, years after marriage, profession, serviceman, businessman, education 1, 2, 3 means graduate, postgraduate, monthly spending on credit card, and income. So these are the variables on which we are going to predict that whether we can predict the category or not. So these are independent variables. So this kind of data we need to run discriminant analysis. Okay. After that, now you go to the analyze, classify, and what class you need to classify using the discriminant model. So discriminant model we are going to apply. Oh, galat ho gaya. Classify discriminant. My grouping variable is customer classification, and here I gave the numbers 1 and 2. So minimum is 1 and maximum is 2. So sometimes we are having 3 categories, 4 categories. So you can say minimum is 1 and maximum is 4, 2, 3, whatever you can keep it. Now these are my independent variables, so I have to take it as independent. Okay. In statistics, I want to see mean, univariate ANOVA, box M, and unstandardized feature. So these, I clicked on all. Classify summary table. This summary table is exactly the confusion matrix. The confusion matrix. So what is the confusion? In how many cases the classification is correct? In how many cases the classification is not correct? So because whenever you are having categorical variable, confusion matrix is one of the output that you need to check. Then we continue. So nothing else, and I click on OK. So here I have to check something and try to improve the model. So this is one output number 1. And let's take the output to the Excel file. Because software gives you some output and we have to generate some more output. Now, how to see this output? So I'm taking only the mean. And this category is the category where the probability of default is high. And the below it, the category is low, where the probability of default is low. So I'm taking these values and pasting here. So this column is representing the high probability, and here where the probability is low. So now I want to compare. So insert, and let's make that this graph. Okay, so this graph is telling me. So the violet color is representing the high risk, and blue color is representing the low risk. Blue is high risk, and violet is low risk. So monthly income of low risk is higher. Monthly income of high risk is lower. It means if somebody have low income, the risk of probability is higher. The risk of default is higher. If somebody is having high income, it means the probability of default is lower. So this seems to be significant. In second case, if the monthly consumption is higher, the probability of default is lower. If the monthly spending is low, the probability of default is high. It means to those who are doing the default, they don't have much spending, they have the normal spending. Education and profession, I don't think there is a difference. Maybe they are having very less mean. Years of after marriage, high in low default, less in लो मैरिज, मतलब जिसकी शादी काफी टाइम हो गया है वो हाई रिस्क, कम समय हुआ है लो रिस्क, हाई रिस्क. तो ज्यादा टाइम हो गया लो रिस्क, कम टाइम हाई रिस्क. सिमिलरली एज, मोर एज लो रिस्क, less age high risk. So we are comparing the mean of the different groups. So in this way we can compare the mean. So this is the first output of the discriminant analysis. Okay. Now in second case, that is test of equality of the group mean. So we want to know that whether all the variables are significant in discriminating the people. So in this case I found that this is not important, this is not significant, this is not significant. Means profession wise, service or businessman, we can't differentiate between the two people, so we can remove this variable, right? Here there is a one problem, that the mean is not different, the mean is not very significant, but I want to know whether this variable is improving the predictability or not, because before removing I have to check this, that if I remove this variable, whether my predictive ability reduces or not. So how we can do that? So if I keep the profession, my predictive accuracy is 95%. My last table is known as confusion matrix, and this table is telling me that the predictive accuracy is 95%. So I want to remove the profession and check whether this probability increases or decreases. If decreases, I will not remove. So let me check that. So after removing the profession, it is same. It is no different. So it is significant. It is still 95%. So it means after removing the profession, I do not have any loss. So let's take this. So in this way, you have to compare the files. So let me run one more time, because in previous we are having two results. Now I have only one result. So I hope now you understand the meaning of test of equality of the group means, whether it is important or not. All p-values are significant. It means all variables are able to classify the two categories significantly, or mean of the two groups are significantly different. After that, we are going to check the box test of equality of the covariance matrix. Okay. Now, actually, some people say that this is a biased result, so don't check the box M test. But just see, actually, what we are testing here, the variance covariance matrix of two groups are equal. Actually, we make the variance and covariance matrix. Okay. So this is high risk group, and this is low risk group. So there are variable 1, variable 2, variable 3, variable 1, variable 2, variable 3. So variable 1 and variable 1, it is called variance of variable 1. And this is called covariance of 1 and 2. Covariance of 1 and 3. So it is called variance covariance matrix. So the assumption is that the variance coefficient matrix should be equal for both the groups. So this is one of the assumption. And if this p-value is more than 0.05, it is true. And if p-value is less than 0.05, then we are rejecting the hypothesis. So it means our assumption is not fulfilled. If you have large data set, then the possibility of meeting the assumption is higher. But here in this case, we are getting the p-value less than 0.05. Okay. Now we are moving to the next table. So in next table, I have two results. One is the eigenvalue and second is the Wilks lambda. What is eigenvalue and what is Wilks lambda? So you know that there are three types of variations: within group variation, between group variation, and total variation. So in ANOVA, in regression, you came to know this. So we are having two things. Let me show you. I have within group variation. Within group variance. So basically I have two groups, group number 1 and group number 2. So variation within the group is called within group variation. Then we have between group variation. And then we have total group variation, total variation. So if I call it X, Y, and Z, so eigenvalue is nothing, it is the Y upon X. Right? So this is the eigenvalue. So eigenvalue is the ratio of explained variance upon unexplained variance. Higher it is, better it is. In this case, you can see that the eigenvalue is 3.5. We want eigenvalue to be greater than approximately 1. In factor analysis, if you remember, we take only those factors where eigenvalue is more than 1. Here, eigenvalue more than 1 is good. 2 is very good. Or more than, higher it is, better it is. So here eigenvalue is found to be 3.5, which is considered to be very good. So in this table, we have to check whether the eigenvalue is higher than 2, and higher it is, better it is. Second thing which you have to see is called canonical correlation. Canonical correlation. Now, what is canonical correlation? Canonical correlation is the correlation between the actual values of Y and the predicted values of Y. The problem here is that the actual value is 0 and 1, or 1 and 2, or 2 or 3, whatever number you gave. If you see, if you remember, the actual values are 1 and 2. But when you calculate the predicted values, it may be more than 1, less than 1, more than 2, less than 2. So whatever value it comes, right? Any value can come. So if we take the correlation between the two values, predicted value and the actual values, the correlation which you are getting is called canonical correlation. The canonical correlation is representing that your predicted values is near to the actual value. The canonical correlation, higher it is, better it is. And any value more than 0.8 is very good. If canonical correlation is more than 0.8, it is considered to be good. So now we are confirmed that our canonical correlation is a good value. So we are happy. Opposite to the eigenvalue, so we are having the Wilks lambda. Wilks lambda is the opposite to eigenvalue. So Wilks lambda is basically the residual variance upon the total variance. Lower it is, better it is, because it is representing the proportion of residual residual in the total variance. So lower it is, better it is. and any value less than 0.3 is considered to be good. 0.3, I'm saying 0.3. It cannot exceed 1. The residual variance cannot be more than total variance, and it is maximum value is 1, and 1 is the worst model. Higher it is, worst it is, lower it is, better it is. So Wilks lambda is a measure of badness of fit. Badness of fit. So lower it is, better it is. So in this case, we can say the Wilks lambda is 0.2, representing that the model is good. Okay. So I hope you have clarity on the two. After that, let's move to the next. Now this standardized canonical function is telling you which is more important, which is less important, which is more important, which is less important. Right. So we want to know that which variable is more important, which variable is less important. Higher the value, more important it is, irrespective of the sign. So you can see that the highest value we found in case of education. The second highest value we found is the monthly income. Then age of the card holder. So the top two variables I found here are, which is important to predict the category, is education and the monthly income. So these two are found to be high important variables. Okay, so I think this is clear. Now after that, so we have to find out this canonical discriminant function coefficient. All these values are representing the beta slope coefficient, and we are using these betas to predict the category. So how we can make the model? Let me take the value in the Excel, because from this table I can make the model. Okay, so how we can make it? Age. The next variable is marriage, education, and monthly consumption or spending, then income, and then constant. So we are having these variables, and the slope coefficient of these variables are minus 0 point, or we can do one thing, we can just copy and paste, special, transpose, and this. So now we take all the values. So I remove this because now it is not required. Okay, so I have these values. This is the slope, and this is the actual value. Actual value or input, you can say it is a, you can put the input. So now you have to put your input here. So you can put it in yellow to represent the input. And now this is it. This is the score. So this is called discriminant score. So how this score will come? This multiplied by input value plus this value multiplied by input value plus education multiplied by input value plus slope multiplied by, अभी कोई input नहीं है तो अभी value नहीं दिखेगी, but when I give the input you will get the score multiplied by input plus this multiplied by input. So now we get the answer. Okay, so it is 0. Why? Because we don't have any input. Now somebody, let's say a new person apply for a credit card. The age is 34. Okay, before that, I'm telling you one more thing. The software also gives you the decision room, right? So the decision rule is coming here, minus 1.853, where the probability is high. So we can paste the decision rule here. Okay, let's paste here, and I take only two values. Cut. So I need only these two values. So the centroid, this value is known as centroid. Centroid. So what is a centroid? I'm telling you. Let's suppose there are two groups. So the centroid of this value is minus 1.853, minus 1.853, and this is 1.853. This is the centroid, this value. Okay, so on the basis of these two centroids, we can divide the people into 4 groups. Okay, so there are 2 cutoff, rather 3 cutoff. If the person lies this range, it means low. This safe means the probability of risk is very low, very low. No risk. The second one is no risk. This is high risk, and this any number beyond this is dangerous risk. Dangerous. So this is dangerous, this is high, this is low, and this is no. So we can divide the customer into 4 categories. This is no risk, this is low risk, this is high risk, and this is super high risk. Yeah, dangerous, you can say. Okay, so in this case, we will predict. Now, I am giving a hypothetical value. Okay, the age of the person is 34, but years after marriage is 4, education is 1, spending is 25, let's say, average income is 34, and the constant is 1. So you can see the score is minus 2.14. So what is the comment? Comment. Now the comment is, okay. So you can make the if command here. If this value is negative, means high risk, else low risk. So software will give you this also. So what is the problem? If is less than this, okay, so you have to give it inverted comma. Because these are the statements. So now you can understand that the model is saying that it is a high risk person. So don't give loan to him. Suppose somebody comes of the age of 25 and the years of marriage is 0, education is 1, spending is 25, income is also 25, and constant is 1. So constant is constant. So you can say the software is still saying that this person is of high risk. Right. Suppose somebody 56 years age come, marriage 25 years, education is 2, spending is 25, income is 50. Right. So you can say the software is saying the high risk. I don't know how. Why? Because high risk, it is because the value is negative. The score is still coming negative. So therefore, the software is putting this person in the high risk. But if you increase the income, so with income, the person is coming in the low risk. So we have developed a model which is predicting the person category. So by the help of this model, you can easily predict that the person belongs to which category. Very easy. Okay. So in this way, we can develop the discriminant model very easily. And you can write this model as an equation. This is called discriminant model. Okay, let's go. After that, we are going to the confusion matrix. The confusion matrix is giving you the 95 prediction is accurate, but it is on the same data set. Because here we are not classifying the data into 3 and 70%, 30%. We are applying the model on the same data and predicting the same data set. This is one of the problem in SPSS, but we can do it. Okay, so this is simply the bivariate discriminant model. So this model gives me the knowledge that the which variable is the most predictive. So we have to check education. So education is having the highest impact. Now, if I run the same model in neural network, so this is my dependent variable, and all the variables are my covariates here, and these two I am putting in factor. Partition 7:3 fine, architecture is fine, training, patch training, gradient, output, synaptic weight, ROC curve, nothing else. Okay. Now I want to check here that what is the confusion matrix, and second, which variable is more important. So the software will give you the entropy. So whenever you see the value entropy, it means the dependent variable is assumed to be categorical. And if you get sum of square of the error term, then it means your dependent variable is assumed to be continuous variable. So this thing we have to keep in our mind. Entropy is representing that dependent variable is categorical. Okay. Now you can see, okay, neural network. This is neural network, 100% prediction. Percentage correct is 100%. And if you see the ROC curve, if this straight line is representing the imaginary worst model, and this red line is showing you the predictive ability of your model. Now, why it is important? If this red is, there are many possibilities like this, like this, like this. The ideal condition is like this. So we are getting the ideal condition here. It means the neural network is able to predict with 100% accuracy, or not only in training data, but testing data also. So I skip one command, that is the So what I missed here is that, yes, this command I missed. So I want to know that which is the most important variable here. So the neural networks say that education is not very important. The most important variable is income, then spending, then education, then age. So a neural network model is denying the discriminant model. And if I ask you to think why it is so, why neural network is giving you better result as compared to discriminant, the answer is very simple. The neural network is a non-linear model. It is capturing the non-linear relationship. However, the discriminant model is capturing the linear relationship. So the this model is better than previous one. So similarly, actually, whenever we run the neural network, we have to compare with the baseline model, some base model like regression, discriminant. So discriminant model is not performing as good as neural network. So this I covered actually the bivariate. I will try to cover the multivariate also. So give me a minute. I have to find out the data set for multivariate discriminant model. So meanwhile, if you have any query, you can ask. Okay. So now what I'm showing you is the multi-category discriminant model. So let me share this slide with you. Okay. So actually, here our dependent variable is Facebook, Twitter, LinkedIn, YouTube, and Instagram. We want to know that which category is preferred by the customers for social media usage. Okay. So we want to predict that which category is preferred by the consumer for, and these are the independent variables. These are the independent variables. Okay. So in this case, my dependent variable are 5: Facebook, Twitter, LinkedIn, YouTube, Instagram. And I want to know that why people prefer which category. So these are the independent variables. So I'm going to apply multivariate discriminant model. Okay, so this is the data set. I already opened the data set. This is my dependent variable, that Facebook, Twitter, LinkedIn, and so on. And these are the dependent variables, independent variables. So these are basically the purpose of using the social media platform. So I'm going to the analyze, damage, classify, discriminant. The only thing that we have in this data set is the 5 categories. 5 categories. So minimum is 1 and maximum is 5. Continue. And these are the independent variables which we are using. So again, classify, we have to check summary table. In statistics, I am clicking on mean and univariate ANOVA. And I have to check unstandardized also. And nothing to, I think this is done. Okay. And okay. So first of all, I want to know that which category is not significant. Surprisingly, all my categories are significant. So there is no need to remove any independent variable. All independent variable are found to be significant. So that is good. And these are the average of different categories. So we can take this, we normally take this chart into the Excel and let me make an Excel. So what I'm doing here, I'm comparing the mean of the different groups and just want to know where the mean is high and where the mean is less. And this graph will give me a lot of ideas that which social media is preferred for what purpose. So a simple analysis we can do. It's a very simple analysis, but it's very effective also. Okay. So it is taking time. Look. So let's go back. Yeah. So meanwhile, Excel is opening, we can move. Now, group mean, it is clear that all group means are equal. Now we have to check the eigenvalues and Willis lambda. Now, the eigenvalues of function 1 is very good, function 2 is very good, function 3 is poor. So percentage of variance is only 6.4. So two functions are explaining the classification better. These functions are nothing where they're the axis, x-axis, y-axis, z-axis, and other axis. The limitation here is that we cannot go beyond two-dimensional graph. That is the limitation with us. Okay. Now I am making this mean graph so that you can understand that how we report the analysis. Okay. So this is the Facebook and mean of the Facebook. Let me delete all. So after that, these are the mean of the Twitter. Cut. This is the mean of the Twitter. So we are having the 5 groups. So let me delete here. We now don't require this. So this is the mean of the LinkedIn, YouTube, Instagram. Okay. So this we want to arrange here. So similarly, you can do for others. This is LinkedIn. Now you can make the graph like this. Insert. So you can compare the mean of the different groups. So like for example, networking in friends is more in Facebook, less in Twitter, and also less in LinkedIn. Marketing your business is found to be highest in LinkedIn. This is LinkedIn, then Twitter, then Facebook. So in this way, you can compare the mean. Okay. So it is a time consuming process, but we have to report like this. After that, we can say that the main conclusion from this table is that the two functions are able to explain the 90% of the variation of the data. So you can see that the 90% of the variation of the data is explained by how many functions? Two functions. So we will make two functions. This is function 1 and this is function 2. And these two functions are able to explain 90% of the data. So we will not go to 3 functions or 3 dimensions. Similarly, if we see the Wilks lambda up to 2 functions, Wilks lambda is perfectly fine. Very low because it is very low. Now, the table which we require is actually this table. So this is function 1, this is function 2, and the first value and second value are known as function coordinates. Function coordinates. And we have to make the graph of these coordinates. So let me show you the graph, because still today we don't know how to get this graph. So we have to make the graph manually most of the time. So we make this kind of graph. And these values like opinion sharing, I'm showing you opinion sharing. The coordinates of opinion sharing is 0.25 and 0.74. Means X is positive and Y is also positive. So 0.25 and 0.75. So it is 0.25. You can see 0.25 and 0.75. So this is a opinion sharing coordinates. So we identify all the coordinates and then we take the distance from the origin, like distance from the origin to all the independent variables. And more is the distance, more is the importance, right? So here we identify the importance on the basis of the distance. Let me show you that. So I take this graph. Let me take here, because I'm not using the function 3 and function 4, so I'm deleting it. So I will calculate the distance here. So what is the distance? Distance from the origin. And the formula which I am going to use, distance is equal to x square plus y square. Why? Because distance between two values is x1 minus square, x1 minus x2 square, y minus y2 square. So I am using this formula. This formula is using, this distance is known as Euclidean distance. However, we are calculating this distance from the origin, equal to SQRT. This value is square plus this value square. Simple. So I calculate the distance. Let's drag and drop. And let's multiply this value into percentage. And let's take the variables also here. Now, let me arrange all the values in descending order, largest to smallest. Okay, I think it is not done. Why? Because, okay, so because it is a formula. So first of all, we have to change the values in values. Now we can arrange it, and now we can plot it. So we will get the plot like this. So what I am saying here, which is the most important variable for preferring for the social media? Opinion. Opinion sharing is the most important variable, which is deciding a factor to share the social media platform. Getting information about the product and services is the second one. Marketing your business is the third one. And the least is business networking and to share photos and videos with others. So what basically we are doing, we are identifying that which variable is more important to decide which social media we will prefer. So this table we have to report in the table along with the this table. And so each red line, each red sentence. So in this graph, I hope you can see the graph. So I hope you can see clearly. In this graph, there are 4 quadrants. So this is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. Now what software is doing? Software is putting all the independent variables into different quadrants on the basis of their coordinates. If both coordinates are positive, then you can put the independent variable in the first quadrant. And if x plus y minus, so it is fourth quadrant like this. And after finding out the coordinates and coordinates, so we take the distance from the origin. Distance from the origin is representing the importance. So higher the distance, more is the importance. After that, so once we plot this graph, after that we want to identify that direction. Magnitude is representing the importance and direction is representing the preference. Like opinion sharing, the direction of the opinion sharing is towards the Twitter. And how we plot the Twitter, I am showing you. The coordinates of Twitter is also coming. You can see that. So these are the coordinates of the function at group centroid. So we will take only x coordinate and y coordinate. For example, Facebook is negative in x and positive in y. So it will lie in the fourth quadrant. So you can see the Facebook is somewhere below. X is negative. Okay. X is negative here. X is negative, y is positive. Let me check. Yeah, x is negative and y is positive. तो x negative कहाँ होता है? तो 0 से left hand side में. Y positive means 0 से ऊपर. So this is the position of the Facebook. This is the position of the Twitter, LinkedIn, YouTube, and Instagram. Now from this table, we can identify that Twitter is used for opinion sharing and interaction with service providers for purchase. Facebook is used for networking with friends and relatives. Instagram is used for sharing pictures and videos. YouTube is used for entertainment and getting information about the product and services. And you can see that there are some lines which are coming in between. Like for example, business networking is lying between LinkedIn and entertainment. So we can say that both LinkedIn and YouTube, both LinkedIn and YouTube are preferred for business networking, because the direction is coming in between the two, right? So in this way, after looking at the direction of the vector, so these are known as independent vectors, we can easily identify that which category is preferred for what. Why Twitter is preferred, why LinkedIn is preferred, why YouTube is preferred, why Facebook and Instagram is preferred. So you can make your comment and just conclude, right? So this is a multivariate discriminant function. So this is one of the report that we make for somebody. So preferential mapping of the selected social media websites. So we reported the eigenvalue. We reported the Willis lambda. We reported the standard canonical discriminant function, taking only x-axis and y-axis. And these are the coordinates of the categorical variable, multi-discriminant. And then we make the graph. And after that, we have to report this graph and interpret the meaning from drawn from this graph. So this is also the advantage of doing discriminant analysis. And you can replace discriminant by the neural network anytime. That is totally your choice. Like in this case, we identified one thing, that the most important variable is found to be share opinion and getting information about product and services. So these two are found to be most important variable. So this we can compare with the neural network also, where I am taking, these are all covariates, not the categories. 7.3, not a problem. Architecture, automatic, training, batch, gradient, output, I need importance, which I want to compare synaptic weight. And I also want ROC curve. So the software will tell me that which is the most important category. So the software is saying that networking is the most important. If you believe that the model is non-linear, then networking is the most important, marketing is second important, opinion is third important. So there is slight change in the results. And if you see the ROC curve, very impressive, because the model is towards the end, and all the categories are successfully predicted by the model. And what is the overall percentage? Overall percentage is 97.9. 97.9% is the accuracy, which is very good. right? So, and I think these are the most important things that we have to report. So whenever you run the discriminant model, although discriminant model is not preferred nowadays, because in 2 examples I proved this, the neural network is far better than discriminant. The reason is that discriminant analysis is linear and neural networking is non-linear and have better robust model. So you can compare 3 or 4 models and to check which is giving you the best of the prediction. So I hope we have completed the given task for today. And now I'm open to the queries. If you have any query related to any subject in research, please ask. Okay, so that's it.
Please, any if you have the query, please write in the chat box. I request all the participants, if you have any query or any question, please write in the chat box. Or even you have to ask directly to sir. I request to all the participants, if you have any query, any questions, unmute yourself and ask the question. Sir, one is mentioned in the Mr. Sweta Gupta, very well. I mean, he mentioned in the chat box for the lovely, I mean, very well explained, sir. No queries. So thank you so much, sir, for the excellent session.
Sir,
So,
hands-on session was excellent, and for the first time, I have experienced 2 research models on the same case study, and it was very well explained. Thank you so much, sir. Thank you so much.
Thank you.
Sir, it will be good if you share the files with us so that we can practice.
Yeah, I will share to Anjali madam and he will circulate with you.
Thank you so much, sir. Thank you.
Or I can do one thing. I can share on the chat box, but at least there are many people who left, so I will share all the PPTs to the Anjali madam and she will give to you.
okay, sir. Thank you. Before we have concluded today, I have proposed a vote of thanks. Dear Dr. Ajay Kumar Chauhan, sir, at the outset, I am sorry for the interruption during the lecture, which was unintentional and mistakenly got unmuted by the participant. Otherwise, I was keenly listening your lecture, and the participants are also lecturing the lecture. Your lecture regarding the artificial neural network was very enriching and interesting. I am sure it must have added the knowledge of the participant, and you have presented your lecture by involving the participants all along the lecture. The participants were also equally enthusiastic and responding to your queries. So we have also given a lot of reference and the different analysis of the 2 models. I hope this would be very helpful for the participant to enrich their knowledge on different software use of the research and descriptive analysis and engage the same in their future research. So it was really a pleasure listening you and hope to have you more in Ramanujan College. Thank you, sir.
Thank you.